In this video, I'll go through the Wilcoxon Signed Rank test, which is used when we have a matched sample experimental situation. So an example of that would be if we're looking at production task completion times in minutes for two different methods, and we use one worker for both methods. So for example, worker 1 completed the task using method A in 10.2 minutes and using method B in 9.5 minutes. Worker 2, method A in 9.6 minutes, method B in 9.8 minutes, and so on. So this is called a matched sample experimental design, and it means that we've essentially just got a single sample to analyze because we can take the differences. It makes sense to take the differences for each worker. 10.2 minus 9.5 comes to 0.7, 9.6 minus 9.8 comes to minus 0.2, and so on. And we're going to analyze these numbers, these differences, to see if the difference, the median difference, is 0 or not. So we'll do a two-tail test for the median. When we're calculating these differences, Excel's a little bit quirky with rounding, and so I'm just making sure that the numbers are rounded to 1 decimal place. And the reason for that is when it comes to ties, Excel doesn't always recognize a tie unless the numbers are rounded. The next step is to calculate the absolute differences. So take all these numbers and give them positive signs, and any ties, so this worker here completed the task in exactly the same time, so the difference was 0. Any ties are discarded from this analysis. Next step is to look at the ranks. So if we look at the data and these absolute differences, the smallest absolute difference is this one, so that has a rank of 1. The next smallest is this one, it has a rank of 2. Next we have 0.4 and 0.4. So these are given a rank of the average of 3 and 4, so 3.5, and so on, all the way to a rank of 10 for this one, which was the biggest difference. And the function that we're using here is rank.avg, so that Excel can calculate that automatically for us. Next step is to look at the original differences, and any that are negative, so this one and this one, are given negative signed ranks. And then all the others that are positive are given positive signed ranks. And then the test statistic is essentially the sum of those positive signed ranks. And that's what I've calculated over here. Comes to 49.5. Next step is to calculate a p-value for that t plus, and we can do that in one of two ways. We can use software like Excel Stat to calculate an exact p-value for us, or we can use a normal approximation and get an asymptotic p-value. And I'll show you that method first, and then we'll use Excel Stat to find the exact p-value. So for the normal approximation, we need to calculate a mean and a standard deviation. So the mean here is labeled mu, and it's given by this formula based on n. And n is the sample size, excluding any that we discarded. So we had 11 workers, but we excluded this one. So we had 10 left that we're analyzing. So that's mu, and then sigma has its own formula, a little more complicated. And then the test statistic will be the 49.5 with a continuity correction applied. And because we're in the right tail here, 49.5 is bigger than 27.5, the continuity correction means subtracting 0.5 up here. And then we subtract the mean and divide by the standard deviation. That gives us a test statistic of 2.191. And then the p-value, it's a two-tail p-value. So the tail area to the right of 2.191 plus the tail area to the left of minus 2.191. So in other words, we could multiply the tail area to the right of 2.191 by 2. That's what we do here. That gives us a p-value of 0.0284. Compare that to alpha, significance level, and if the p-value is less than the significance level, reject the null hypothesis, and it is. 0.0284 is less than 0.05, so we reject the null and conclude that there does appear to be a difference in the medians for the two different methods here. In particular, because we got a bigger sum for the positive ranks than for the negative ranks, it looks like that difference is positive. So looks like method A is taking the workers longer to do than method B is. Okay, let's see what XLStat gives us for the exact p-value. So it's a non-parametric test, and it's labeled as one sample Wilcoxon signed ranks test. And that, again, is because we've got a matched sample design. So we're really just looking at these differences. And when we select the data, that's the data we'll pick. We're not going to select the original measurements. We'll select these differences here, which we've calculated already. And then under options, we'll do a two-tail test. Theoretical median of 0, median of the difference. And we'll do an exact p-value calculation. And here's the results. So it confirms for us that T plus, which it labels V, is 49.5, and then the two-tail p-value up here to 4 decimal places, 0.0282. So that's what I've written here. So very close to the asymptotic p-value and leads to the same decision. 0.0282 is less than 0.05, so we reject the null and conclude that there does appear to be a difference in the median completion times for the two methods.